Tools for economics and management. The topic for today is related to root finding, and hence we will essentially use a method to solve an equation like f of x equal to 0. This is exactly what root finding means. So you should learn that whenever I ask for roots, I am indeed asking for the x's such that some expression or some functions, for example f of x, is equal to 0. After that, we will briefly review discounted cash flows. This is something which is useful in order to understand how to evaluate bonds, and in particular BTPs, which is our point number 3. And finally, I would use the previously seen root finding technique in order to compute the gross return of a BTP, which is an Italian government bond. So first of all, let's move to root finding. So consider this function. This is a fourth degree function, f of x. You can read it here. And finding the roots really means that you want to find the x's such that f of x is 0. First of all, you should ask yourself, how many roots do I have? How many solutions of the equation do I have? And so a graph is going to be useful. The second important question that must be asked in order to find the roots is which is a bracketing interval. By bracketing interval, we mean an interval in which there is a unique root, and this is needed for R to compute the root. So having said that, you can look at this graph, which is obtained just defining the function as you see, for example, here, and then plotting the graph using the function curve. I am plotting the function, given that I have no previous knowledge about this specific function, on the interval -3 to 3, and of course here I can see something, but clearly the graph should be more insightful. But even in this rough graph, if I draw the horizontal axis, which is done typing AB line horizontal equal to 0, I guess from this graph that maybe I have one solution here and one solution here. Of course, it is very difficult to see the solution using such a graph, and hence I should move to a better graph, for example, this one. So if I just zoom on an interval in order to see better what's going on, so for example, if I type curve f on the interval -2 to 1 and I draw the x-axis, I see the points where my function, the y, is 0. And I see that there are a couple of points. One point is here, and the second point is there. And once I have such a clear graph, I am ready to provide a bracketing interval. For example, if I am interested in this point here, I see that this point is within the interval -1 to 0. So my first bracketing interval is indeed the interval going from -1 to 0, and hence I am ready to use the function uniroot, because I know that there is a root, I know a bracketing interval, meaning I know an interval in which there is a unique root. Mathematically, this means that I know an interval in which the function changes sign at the extreme. So for example, here the function is positive at -1, but it is negative at 0. And there is a theorem stating that in this case, I am sure that there must be a solution within the interval. Once I have that, I can just type uniroot f, comma, the interval, and I will get an approximation, a very good approximation of the root, which in this case is -0.67. I can see some other information here. For example, here you see the value of the function at the root. This is a very small number. It is 7 times 10 to -7, which means 1/10 of a billionth. This is a very small value for the function, and indeed I was looking for a point in which the function was 0. It is not indeed 0, but it is very small. It is 10 to -7. And you can see other technical information here, but we will not be concerned about that. Let me now move briefly to discounted cash flows. So the main assumption and the main intuition is that there is some time value for money, meaning that an amount available in the future is worth less than its nominal value. I mean, if you will get 100 euro, for example, in 1 year, clearly 100 euros in 1 year are less valuable than 100 euros now. And in order to formalize this intuition, we say that the future money should be discounted. Should be discounted in order to take into account that it is worth less if I value that amount today. So how we formalize this intuition? So assume that you are in t equal to 0, which is basically now, and that you have some sum x available in some future time t. Then you can compute the discounted cash flow of the amount x at the future time t. This is going to be less than x, and in order to do that, I will divide x by some factor which is bigger than 1. And this factor is depending on two things. You can see that there is an interest rate r. This interest rate is positive. So here you see a base, 1 plus r, which is bigger than 1. So indeed you are reducing the amount x because your denominator is bigger than 1. And your denominator will be larger if the time t is large, because money available far in the future will be worth less will be worth less and less. So basically this is the way to discount future amounts, and it is an approximation of how much is worth an amount which is available using some discount factor r in a future date t. So this was holding for one single amount, but what's happening if I have many amounts? Well, basically assume that you are in a situation in which you evaluate a stream of cash flows at time 0, and you will get, for example, money at time t1, at time t2, and at time t3 here. Well, if you also can assume that in t1 you will get an amount which is x1, in t2 you get an amount which is x2, and in t3 you get an amount which is x3, and so on. So basically this is a very nice graph telling you, using a unique representation, the times in which you will get the money and the actual amount of money that you get. So basically you just have to sum the discounted cash flows of the three entries here. So if you want to compute the discounted cash flow of all this stream, you just have to sum the discounted cash flow relative to the first time and first amount, which is x1 over 1 plus the interest rate raised to t1, plus, and we are now taking into account the second cash flow, plus x2 over 1 plus r raised to t2, plus, and we are now taking into account the third cash flow, plus the third amount over 1 plus r raised to t3. And basically you can, this is an easy formula to compute discounted cash flows for stream, and we are ready to move to BTPs now.